Okay, hi. That's bad. My name is Joseph Wilk. I'm one of the core developers of Cucumber, and I also work for a startup called Songkick for the last 2 years or so. And I'm by trade mainly a Ruby developer. In this talk, I have a lot of meetings with various startups, and often it's just a case of explaining how you do things, how your company functions. And startups can change so rapidly that it provides a really a dynamic environment. So kind of treat this presentation really as me kind of setting a little bit of the scene as what does it mean to have acceptance tests in a startup, having a little look at Songkick where I work and some examples about how we work. And then just looking at some of the lessons that we've learned and me just rambling about a whole bunch of stuff I want to squeeze in. So, what is a startup? Eric Ries gives this definition: an organization dedicated to create something new under extreme editions of uncertainty. So, you don't even know if anyone wants your product. You don't even know what your product is. You probably don't yet have a business model. You don't even know what technology you should be using, right? I mean, there's so many unknowns for a startup. Is that going to work? Yeah. And what are acceptance tests? Well, acceptance tests are customer-facing. And I like that phrase as in you put it in front of a potentially non-technical customer and they can understand what that says, what it describes. And usually it's about some expression, some behavior of the system, explaining how some feature works. So it's actually fairly rare for startups to have acceptance tests, to be honest with you, to do pretty much any testing at all. And I like to rephrase this question as acceptance tests for startups. It's more, does it make sense to use acceptance tests in extreme uncertainty? When you don't even know if you've got a valuable product, where you're hacking in your evenings and you're trying to scrape together a business model. Is it worth investing time and effort in writing acceptance tests? Well, for this I like to reference this Siphon model. This was some research done by David Snowden. And what he did, he categorized a whole bunch of research using psychologists and systems analysis and systems thinking and a whole bunch of other schools of thought to come up with these definitions of environments and systems, whether a system could be complex, complicated, chaotic, or simple. And he categorized a set of actions based on which environment you're in, as in a way to react and respond when building something in that environment. So often we start in this chaotic phase with a startup. And he specifically states the best way to deal with chaos, right, is to get something out there as fast as possible, to act, to build something, to release it. And then sense the feedback, use the metrics, assess, is this being successful, are people using it? And then responding to that, making changes potentially. So the traditional software model is probably sitting in this maybe complicated or simple phase, where in fact we actually do a whole bunch of analysis up front, and we may set a bunch of requirements, we may work on a feature for a while, and we then release it. So this chaotic model is much more about get the code out fast, which is fairly kind of the hacker mentality of, just hack it out as fast as you can. But there's this 3-cycle phase that's, I think Eric Ries came up with it again, called the build, measure, learn cycle. So in startups, we'll build something, we'll measure its success, we'll learn from those metrics, and then we'll go away and maybe rebuild something. But this build phase of actually writing software can be very different. For example, this cycle, if you're building something and you don't build the right thing, you go back, you build something, you don't build the right thing. This build phase can in fact be very large. So even in a startup environment where you're kind of building as fast as you can, there's a question over, are you building the right thing? Do you know what you're building? This is where one area where acceptance tests could fit in. But they could also be restrictive as well. If we look at this build phase, if we sit down and write a whole bunch of acceptance tests, a whole bunch of UE testing potentially, and a whole bunch of unit tests, that might be slower than us just hacking out a bit of code and releasing it. So there's a trade-off of assessing how do we minimize this build phase so we can get to this measure as fast as possible with the right thing. So in a startup, you pretty much start with like this uncertainty and fairly high, complexity being fairly simple, usually, well, generalizing, but usually you have a very simple idea to start with. And your team size is usually yourself. And progressively, as your startup develops, uncertainty decreases, complexity increases, and your team size increases. So as one developer, from my own experience working with my own startup ideas, I pretty much sometimes don't write tests. I just hack it out. I can keep the code in my head, have a good mental model of it. I don't have to communicate with anyone else or share any ideas with developers, so I have no real reason to write tests. I feel the value of getting something out faster, and the fact that I can keep that code in my head means that's enough for me. But as we said, your team size is increasing, right? This one little hacked idea turns into, a team of 20, 30 people working on this project. And immediately that's where you start screaming for tests. And this happened where I worked at Songkick when they first started. It was hacked out over a weekend in Boston or something. And then suddenly, they got funding and a bunch of people came into the team. And this is where testing and acceptance tests basically enabled a form of communication between all developers. So people could actually, not break other people's code. You have 20 people who are walking in different areas of the app. It just is chaos without that testing or acceptance testing stuff. So where I work is a company called Songkick. It's been going for about 4 or 5 years now. It's VC funded, but it started as a very simple idea all around live music. The team has probably grown to about 30-ish people now. It started with 2 people working in their family attic and progressed to this size. Let me just grab some water a sec. So Songkick has a couple of core principles which are fairly, popular with startups now. But as a startup, we totally embrace change. We have, I'll come on to a bit later, but we've used Kanban stuff. We've literally thrown it away, tried something completely different for a week. That failed, throw that away, try something else. There's no fear of rapid change and just trying stuff. We have confidence that everyone in the team will get a good idea if it's working or not. As a product, you kind of hit this interesting idea in that we are not profitable. We do not make money. So what we're about is growth. And what is absolutely fundamental to growth is the user experience. It's all about that funnel of getting as many users as possible to use this site and getting people signing up. So as a company, we are completely UX obsessed. And this goes right through to everyone in the team. I'm going to discuss a little bit about some of the stuff we do around that. And testing. Again, quite rare for a startup. Basically, we hired a couple of people very early on who were really into other XB and BDD sort of stuff. So there's been a real infrastructure around testing set up. So we really believe in testing, trying to scale this company and scale this startup. And we use a tool called Cucumber. I kind of want to have a brief touch on Cucumber because I'm one of the core developers and I like the opportunity just to briefly mention it. But this talk is really more high level, so even if you haven't used Cucumber, I hope there's lots of lessons and things you can take away from this. So Cucumber for me comes about from this problem that I think is really well stated by Martin Fowler. And I've been on a lot of these projects. The main source of project failure is the lack of communication between people who want the software and people who are writing it and creating it. And he goes on to talk about how a domain-specific language, some intermediary language that can be used by both parties, the people who want the software and the people who are building it, can be a way to improve communication. I mean, that's a really blindly obvious way of stating, if you write something in a shared language that everyone understands, you might help build the right thing. And that's not too important what that says. It's the fact where I mainly work with Ruby, and Ruby has a beautiful DSL style language to it. As a developer, you can write things that practically read as sentences. But as I said, this is about communication, and programming language isn't good enough as an intermediary form to communicate with other people, potentially non-technical people. It already has a bunch of syntactical rules. It's much more constrictive than if I just open an Excel document and start typing stuff out. But one of the key things that I find Cucumber brings us, and as I was saying, this kind of intermediary language, Cucumber is all about this ubiquitous language. This is a phrase that I think Eric Evans came up for in a book called Domain-Driven Design. He talks about this ubiquitous language, the idea that everyone is using the same language for the company. When I say a logged-in user or a visitor, everybody knows what that means. Everybody knows, oh yes, that's one of those guys who signed up via this web page, etc., etc. So it's about having consistency in a language, and it's about the fact this ubiquitous language should bleed throughout the entire software development process. When I write a little bit of code, I should be creating my database tables with the names of this ubiquitous language. And I think Dan North gave a really good example of how important this ubiquitous language was, where two developers were, I think in a trading system, were discussing some class and its responsibilities, a very technical conversation. And a trader was walking past, heard this conversation, and kind of went over and corrected me and said, no, you're talking about this, this liability, that doesn't work that way, it works this way. And they were discussing code and classes. So it's this key thing that this language is bleeding through the entire development process. I've seen, I think probably most people have seen where you get to some sort of thing like a database table where something's called like what do we have? A metro area. And like no one knows what that means, and the meaning changes, and it's just a source for confusion. And if we're trying to build the right software, trying to minimize that build phase and try and get things out fast, we really need to be able to all speak in the same language. So a very brief overview of Cucumber. Just out of curiosity, how many people have used Cucumber? Okay, so this is just going to be a very brief overview of Cucumber, which will help convey some of the further points in the presentation. So Cucumber set out with a bold goal to define the language that every tool uses to talk about the behavior of a system. And it did this with this thing called Gherkin, which is the kind of the language we write this plain text stuff in Cucumber. So the whole idea of this is to have some specification in a very natural language form, which has no programming language in it. It's very loose. It has a lot less syntactical rules. Non-technical people can potentially interact with this, understand what it means. And Cucumber then has the coding side. It uses regular expressions to map all that plain text to testing code. So, go back a sec, there we go. So like something, when I submit something, will actually have some regular expression which matches that, and then some logic. So Cucumber, I shouldn't say this, but Cucumber to me is just like a stupidly simple tool. It's about matching plain text to test code, and that's what Cucumber is all about. Well, that's the function. Within our test code, we're often using things like, we haven't mentioned like capybaras, Selenium, various support logic about simulating, potentially interacting with forms or UI elements. The automation, actually the drivers, we might be using Selenium to launch Firefox or potentially any different type of browser tools. And ultimately, the system under test, the thing that we're actually testing. So this represents like the full stack of all the different levels of Cucumber. And it's really just a very brief insight into some of the functionality of Cucumber. There's a ridiculous amount of information and presentations and talks and books about Cucumber. So if you want any further references, come grab me and I'll point you to it. So going back to Songkick, I want to look at the way we work. And I've gone to enough conferences and I kind of get really fed up with these companies or people coming from companies and saying, yes, this is how we work, this is the way you should all be working. And that is completely not the case. And in a startup, literally we're like, ad hocing every day. What does this do? Is this working? We're continuously trying new stuff. So by no means, this is not the way to develop software. This is a bunch of stuff that we've tried, and some of the stuff which is working for us, some of it maybe not. So really, we really don't know what we're doing. We're just making it up as we go along. So we use Kanban. What does that mean, use Kanban? Well, oh man, that's too dark to show that picture. That sucks. Oh, you can see that, okay. That's annoying. So this represents a board, which is probably from this projector right over to the far side of the wall. It's 3 massive columns where we stick a whole bunch of cards. And these cards move through the various columns representing the process of adding value to the product. So like the requirements, the testing, writing the stuff, getting it tested with users, a basic flow. What's very annoying is this is massive, and recently we ripped this completely apart and created just 3 columns. Again, this is what I'm talking about in terms of like not just doing Kanban because Kanban is the way you develop software. Realizing that we, a bunch of very technical people, give them the opportunity to try and create a way of managing and processing development. And what I continually see is they'll go away and like, this green card means this, and if we put a pink spot on this card, that means it's got to be prioritized. But if it's got 2 pink spots, then it should be even more important. But if it's got a blue spot, like ignore it. And like, we have a really bad habit of creating very complex systems, and you give that to a technical person and they run wild with it. So this really represented a like, okay, people don't understand what this board does, what's the point of it if people don't understand it? So we ripped it apart, literally have this idea of stuff that needs to get done, stuff that we're doing, and stuff that we've actually delivered. I'll go into the definition of the transition between these columns as well a little bit, but when we say Kanban, it's really just about having a board with a bunch of cards which represent how we work and the flow of value as we build things. So I'm going to look through a feature that I've recently been working on relating to Facebook. I hate Facebook, but I've had to work on it. Anyone who's worked with Facebook hates it. So where do features come from? Rolling back to it, where does work that needs to get done come from? So we very much run upon the principle of anyone who wants to get involved in a conversation comes along to that conversation. So when we're thinking about what work needs to get done, people will hold a meeting and people will just basically, I consider it like bartering almost of like, I want to get this done, I want to get this done, let's do this. And it's just a discussion of people working out and prioritizing what sort of stuff we want to get to. This again, puts in the backlog and gets picked off. So we decided to, we were given a stat by Facebook which indicated that if we had a sign up through Facebook, i.e. you just log in through Facebook, you don't do your username, your password, your address, etc., that more people are likely to sign up. So the first thing we do is create this minimal marketable feature. What's a minimal marketable feature? The key idea with this is it's minimal, it's the smallest possible thing that you could build that can deliver some sort of value. In this case, you also notice that we have something very key about these things, that they're measurable. We can assess the success of this feature. So in this one, we were aiming for a 10% increase in sign-ups. This is something that we initially didn't do, and like features kind of just prolonged in the system, and no one really went back and thought like, why did this work? So we really have a very stringent, this isn't doing 10%, is it worth us adding complexity to our software? Do we really want this thing? Has it delivered? From that minimal marketable feature, we'll go away and brainstorm a bunch of scenarios. Again, whoever wants to get involved in this conversation, it's usually a cross-cutting, like a developer, a QA, I don't like the name QA, but let's say a developer and a tester, and a developer who's testing focused, and usually a product owner, anyone who wants UX as well. We brainstorm a whole bunch of examples, and then we usually pick what we refer to as the exemplars, the key examples that best express a requirement. And we just write this little narrative, this what's referred to as the feature injection style, defining the value on the card in order to sign up as little effort as possible, the role, and actually what the feature is. And here we broke this up into 2 very simple things, just success and failure. Notice we haven't actually described what these things mean in detail, we've just got these high-level cards. These 2 things need to be go away and built. Again, one of the things you start to see with Kanban is we make the units of work as small as possible. This comes from a whole bunch of queuing theory that's probably a bit too much to go into in this presentation, but put very simply, the smaller your pieces of work, the shorter your queue is to get something out and deployed and delivered. So if you do lots of small bits of work, you're delivering value much faster than if you're doing big batches. So batch size affects our cycle time. So we have these pink cards, and at some point someone comes along and grabs them, and grabs a bunch of people together to have a conversation. Again, very ad hoc. You know, these aren't formal meetings. There isn't a wall between these various parties. They just come together and start talking about how they want to build this feature. Often this involves sketching. As I said, we have a lot of user interaction stuff, so often this is scribbling things on boards and like, you know, just like, what does this mean? What is this Facebook thing? What's the developer? What's the requirement of this thing? What's the technical constraints? What have we done in user research? How do we want the user to interact? How are we going to test it? What are all the weird and wondrous cases that Facebook can break? Don't worry, this is the back of that pink card that we just saw. So what often happens as an output of all that discussion is we get these key bullet points on this pink card, which really represent the acceptance criteria of this card. I'll come on to it's very important to distinguish, this isn't our definition of done. This feature isn't done when these criteria are met. These criteria met what we think we need to do in order to deliver this feature. So some of these things are what happens if Facebook goes away? We should probably send them, try and redirect them to the normal login. Lots of really horrible things that the QAs came up with, and we were like, yeah, that's one of those tricky edge cases that we would like to not think about. It got written on the card. With that, we go away and usually then start pairing and writing the Cucumber features. So this tends, I as much as possible, tend to sit next to a person working in the testing QA side of stuff. And we will sit down and start typing out Cucumber features. But the very key point is, I will not enforce in any way whatsoever that it has to be this gherkin syntax we've been briefly mentioned. What I will simply do is start typing out these, based on that pink card, various okay, so given the user's hasn't logged in and they log in with their Facebook account and their Facebook account's valid and everything happens nicely, it goes well. Just very, very brief discussion and description of the behavior of the system. And then I will refine these into Cucumber gherkin features and then just go back to the QA and review them and say, is this what you meant? So, not enforcing people to write Cucumber gherkin features, because I don't believe that works. Just using whatever's most natural, and because we want to make these executable tests, there has to be some level of refinement to make them automatable. So this represents the Cucumber feature that we wrote for one of these. I'm not going to go into too much detail here. One of the brief things I want to cover is the different components of a Cucumber feature. Cucumber really has very little rules about what you put in here, but we can see this Cucumber feature as the specification of this feature. We have that pink card value here, reducing friction in signing up as a non-member. I want to sign up for my Facebook account. So we've captured the value and we've moved the value as close as possible to the code. So whoever's working on this project, whoever the developers are, they know why they're building this thing. And if this thing is not, if they don't understand what this thing is, or they believe it's not valuable, they'll go and ask why. Why are we building this? What's the reason for building this? There is never the culture of this is what I do, this is what I go away and do. I've seen countless times developers give them a feature and they'll say why am I doing this? We already do this. And someone not realizing that there's some feature or suddenly realizing this thing isn't important. So there's questioning of this value throughout the system. And also this can affect the way we build the software, how we decide what to build as a developer. We have the specification part of Cucumber, of this Cucumber feature, which is really just describing what we're building. As I mentioned, we tend to have a lot of UX interaction. So often this is about having mock-ups, having links to various, go look at Basecamp for this picture that we took. Because again, Cucumber is text, is ASCII, and try and communicate with ASCII to designers is just futile. Pictures, images, sketches, are very valuable forms of communication. And something I want to reinforce over and over here is that Cucumber is a tool which helps facilitate some of this stuff, but really the ultimate thing is these conversations and discussions there.
Then within the Cucumber feature, we have these examples I was just talking about. These, given, when, then language of describing,
given some precondition, like I have a Facebook account, when some action occurs, like I try and sign up, then, I should be signed up, I should see the sign up page, I should have an account. So the key thing here is that what's considered is with a specification, examples are the best way to understand a specification. So this thing tells us what we're building. This thing helps us understand it through working through examples. This is one of the key ideas behind Cucumber, and really pretty much any requirement capturing sort of way of thinking about things through examples. I had an interesting question someone asked me about how you get people to interact with Cucumber features when potentially these are close to the code, committed in some source control. One of the key things, if you want people to engage with these features, is to expose them through some sort of really easy, low barriers to entry, per example, this sort of website. So every time we every time we have a green build, we automatically generate this HTML documentation stuff for all our features. So literally before we've even actually written any code, we have these things published, and everyone in the entire company can go to this page, have a look at it, read what this thing does, and again, question, have more discussions potentially. So it's very bad. Otherwise, I feel your features just tend to rot in your source control, and they become crafty, like they become more developer-centric because people aren't reading them. Like, technical language starts to creep in, and you lose the value and the reason why you're using something like Cucumber. So then developing, I'm picking up these Cucumber features and then I'm actually implementing them. Again, I always sit next to a QA when I'm doing this, because this is where I'm continuously going, oh crap, what about that? And what did you mean by this? And to me, as I said, I don't really like the term QA, like the tester, developer, is usually the domain expert. So usually they understand things better than I do. I don't understand the domain as well as they do. The developer working with them more. We use Jenkins, or what was it called? Jenkins or Hudson, as it previously was referred to. We have a whole bunch of stuff plugged in through Jenkins. We use Jenkins for all our deployment. So anyone can deploy code just by clicking a build, and it's logged so everyone knows if something went wrong. Literally anyone can do this, which is very, very key. We generate a whole bunch of metric information through Jenkins. There's loads of great plugins. If you're using Cucumber, there's this great JUnit format you can use with Jenkins, which provides you this nice test trend and gives you like a breakdown of your test failure rates. So if you're using Cucumber and Jenkins, check out the JUnit format. So this is the key, like literally anyone in the entire company can deploy. The cleaner can click the build button and they can deploy the code. Well, they probably shouldn't, but they could. I was talking about that definition of done, and like often people say like your acceptance criteria is your definition that you've delivered what you meant to deliver. We don't have this. What we have as a definition of done is that the metric has been met that we talked about earlier, and that a user has validated the value of that feature. So what this means is we do a lot of UX testing, and developers, literally anyone in the team, if a developer worked on a feature, they will go and sit behind a two-way mirror and watch a user use their feature, and see that user go, now this is what I want, or see them maybe not validate it, in which case we need to go away and think about, do we throw this away, do we try again? Or the rewarding thing of seeing a user go like, wow, this is really useful, and them actually get the value out of it. So the key thing is we do not consider the acceptance criteria the definition of done. We consider a user getting value out of our feature as the sign that we've actually done what we set out to do. So I've got a bunch of lessons and ideas and stuff that I kind of want to share that I hopefully will be useful for you guys, and will hopefully explain some stuff we've learned. A lot of this is pain, actually. We've done a lot of really bad things and really crafty stuff with Cucumber and testing, so A lot of this is stuff that often people brush under the carpet, but we've done things badly, we have really. So something we have a lot is that with tools like Cucumber, often there's the assumption that you can just do full stack testing and you're testing through a browser. And what I started to find was that developers could very quickly create like a high level, cutting through the entire application stack test and get that to pass and just do that and not write any unit tests, but have very little test coverage. And you know, their big high level thing goes green. They get a lot of confidence from knowing that this browser or whatever they're using has actually done what they set out to do. So the confidence level is very high, and what isn't being questioned is that the increasing feedback loop in checking that everything works. So what happened was we literally, what was it? Around 10,000 Cucumber steps, which probably ranges into 300, 400 features. And to execute all of these Cucumber features took 9 hours on a single machine. We distributed this over 20 EC2 machines and cut this down to, I think it was like 13 minutes. And this costs $5,000 a month to do, which is absolutely ridiculous. Again, like we saw the problem as like, this was easy, we did this, we were lazy, this got us there quickly. But it left us with this ginormous problem of the fact that suddenly, you know, our value stream, our ability to deliver software was stuck by this bottleneck of waiting, you know, X hours or hemorrhaging huge amounts of cash, paying lots of build slaves. Also, we missed a lot of design with this, and I think a lot of people forget this, and there was some discussion about using Cucumber or RSpec and testing tools. In my idea, both fit as useful tools, because the unit tests are really what give you design smells about how you write your own app. And something I've had to go back and do a lot of rewriting and work on is people have written code that isn't easy to test. Because it doesn't matter at the low-level units it's easy to test. It matters that you can test it through a very high level, cutting through the entire stack. So it really does produce often architectures which are hard to scale, hard to work on, hard to distribute among teams. That's where unit testing really comes in. Something that I've been doing a lot of work with Songkick is, I guess I kind of come from a real like testing background. I've always been very focused on never writing a line of code unless I have a test to make that pass. But what I've started to realize more and more at Songkick is this compromise between safety and speed. To give you some extremes, Songkick was probably sitting on this safety side of this equation. We had, you know, this 9-hour build, but we really were very confident. It took us, you know, maybe a release every 3 days or something, but we were very confident we were deploying working code. Versus this speed equation, there's a really good example of I think it was a trading company, it was a stockbroker, I think. And what they decided was that they weren't going to have any tests at all. They weren't going to have any automated tests. What they were going to do was, when the new system got deployed, they'd push $100 for it. If that went okay, they'd push 1,000. If that went okay, they'd push 10, hundreds, into the millions. So in their eyes, in that marketplace, it was more important to be fast in deploying features and improving systems than it was to lose maybe 1,000, 10,000 bucks to just some bug. So often I think people kind of veer on this safety, but there are lots of interesting things you gain from this speed thing. And I know a bunch of companies who are very much focused on, I guess they're still testing, but they're testing on production, they're testing the live system. So it's not stopping them deploying their code. What I've started to do at Songkick is build different feedback loops into my Cucumber features and our test suite. So when a developer commits any code, a build is fired off, and that will run everything below the UE level. It will cut underneath the UE. It will be a very fast build. Then, when the code gets deployed, we do this thing called a canary deployment, where we deploy that production code to 1% of our traffic on one machine. And we will then have Cucumber run against the UE, so we can kind of ad hoc choose the way Cucumber works across the UE on that production machine. So users are hitting that site. We then have live metric measuring of, you know, checking the number of 404s we're getting, checking like any exceptions we're getting. Very, very tight monitoring of that box. If the Cucumber features are green and that box isn't raising too much errors, then that code gets distributed to all the traffic. Again, this has the advantage of all it is flicking a load balancer switch, which we've done instantly. So it's a very nice way of taking code off and taking code on. So I guess what I'm saying with this is that Songkick, we've realized that we err too much on safety. And now we accept that we might break things on production. We changed our feedback loops so we could react faster and get our code out faster. And we've realized that we want our tests to have different levels of feedback, so we can choose if we want to run something very fast, if we want to run something coming through the entire UE. Which means now we do like deploys well, we probably do like 2-3 deploys a day now, which still isn't fast enough for what we want, but it's a big difference from having a 3-day time to deploy code. So I mentioned this build, measure, learn cycle. Build the software, measure with metrics if it worked, learn from those metrics, and repeat, iterating over your idea. Something we've done at Songkick is switch things around a little and not actually build the feature, but change the order we do things. So the very first thing we do is measure, we learn from that, and we build. It sounds a bit odd. To give you the example we did it with, this is the Songkick website, and what we wanted to discover was that we wanted to increase sign-ups. This is the metric we were working on. And to sign up, people had to enter a bunch of details. So we wondered what would happen if we just put like a button on a page with someone being able to enter their email address and just hit a button. And that would instantly sign that user up. No one really knew if this would just generate a whole bunch of spam or loads of people would sign up and it would be a disaster. So, and actually we looked at this feature and we realized that this could potentially massively increase the number of users we had in our database, which means we would have to deal with a lot of scaling issues. So instead of building, we just released the UE with like literally all this was doing was writing to a text file. So people hit the sign up here and they hit the button and it didn't actually do what we told them it was going to do. They literally just wrote to that text file. And then we were like, okay, let's measure that. Let's see how successful that was. So like in the first day, we had like 100K people click that button. So we were like, holy crap, we've measured this as successful. We should probably go away and build this thing now. So like you see like the value, like if we'd actually tried to implement this feature, we would have spent months working on loads of scaling stuff. We very rapidly learned by releasing something, thinking about that Cybin model of complexity. We quickly pushed something out, sensed whether it was useful, got the feedback, learned, and then released the code. So often this is what we talk about in the whole lean startup movement of we measure our progress in learning, how much we've learned rather than how much we've built. Something I should briefly mention with Kanban, and something that adds a lot of value to our team, is the idea of limiting the amount of work in progress. Bypassing the whole queuing theory stuff of this. Literally this means in that Kanban board, only 4 things can ever be worked on at once. If you finish what you're doing and you want to do something else, and there's 4 things in progress, you don't do any work. Well, that's why that came out wrong. You do work, but you don't start building any new features, because you would breach the limit that you have on working. So the idea is you do something else. You go away and add value, you start improving some crafty tests, you build value in. But what we often find with this is like, okay, I can't start this new feature because there's too much in progress at the moment. So the QA seems, or like the testing team seems to be really under push and they're testing like 5 things at once. I should probably go over there and help them reduce the bottleneck so I can actually then start a new feature. So to me, Kanban and this whole limit term progress really spawns this idea of like multi-skilled teams of, if I'm stuck, I'm going to go be a tester because that's where the bottleneck is. What's key is removing the bottlenecks, not necessarily just being a developer and just saying, oh well, I shouldn't do any work, or I should start loads of features and put even more pressure on the bottleneck. Multivariate testing. I'll briefly go on this one. This is the problem of like A/B testing where you try out. For example, we did one where we had a pink button on the sign up and a blue button, and some random stat, 10% of people clicked more on a pink button than a blue button. It makes no sense to me whatsoever. That's what we learned. But from a testing perspective, you're like, crap, now I have 2 permutations to test, right? And then like the team was, well, let's try a blue, a pink, a red, and orange button. So now suddenly I have like this state explosion problem with testing, right? Suddenly, my one test turns into like, hundreds of tests. With this, we have a couple of approaches. We use this idea of pairwise testing. Pairwise testing has a little controversy over it, but it's really the idea that it's a way of dealing with lots of permutations and using the fact that often errors in software are caused by the interaction of 2 things. So rather than testing every possible permutation, you just test every possible 2 combinations. If you haven't heard it before, there's loads of writing and stuff, and there's a bunch of tools about pairwise. The other thing we do is we just decided not to test all these various cases and just make sure the core one that worked before, so we can roll back, is tested, and have these things as actually manually tested, because it simply became unfeasible and a blocker. And the whole point is to learn fast, right? Like we're doing 10 things at once, which one works? Oh yeah, I forgot to put the animation in. Come on, next slide. Cucumber really started as a developer-centric tool at Songkick. I guess we're guilty of that whole kind of like we like shiny new toys, especially in the Ruby world. So we saw Cucumber and we were like, wow, that looks great, and I helped write part of it, so I was like, yeah, we should use that. I'm very unbiased. And what we found, in fact, we actually found it quite late, that the QA were testing a bunch of stuff we had in automated Cucumber features. And this came about because they did not trust the features. So this is one of the key things with testing, is helping build trust in your tests. If a test is green and someone goes to the website and it's completely broken, they lose any faith in that test, which kind of defeats the whole purpose of like, you have these tests, but don't worry about testing if a user didn't sign up. This is the most important thing we have in our site. So we have smoke tests, we have all Selenium stuff testing that. You go in, do exploratory testing, push, discover new wondrous, weird ways you can break this feature. So again, this really came about from being too developer-centric and not having trust in the tests. Building trust, there's no easy solution. It's really just expending the effort and making sure your tests are robust. And as a developer or whoever, just not taking your test as golden, but actually then loading whatever it is and actually interacting with it to check it works. Because testing isn't infallible. I mentioned about this definition of done. Just to reiterate, we do not consider a feature delivered until it's in use in production by real users and we validated that it's a useful part of our product. The reason we did this was because nothing ever got removed. We just kept adding features and we got feature bloat. And we suddenly realized, we had all these A/B tests, and it became so complicated understanding why the code with sign up had like 10 special cases of if you came from this site, you went this way. If you came from that site, you went another way. So really we started to think, like, let's think about the users and let's really connect developers to the value they're delivering to users who are building this feature. And I think this is absolutely critical. There's nothing more rewarding that I find as a developer of building something and actually seeing a user go, wow, that's cool. It's a very rewarding process for devs, and everyone really. Something, as I kind of mentioned this a little bit earlier, but since I've spent the last 3 or 4 years working on the Cucumber source and running workshops, training loads of people, people often expect me to kind of sell Cucumber to everyone and think it's like the only important thing. What I often tell people is, to be honest, you could use any tool you want. Cucumber, Fitness, just use unit test, like test unit, anything. The Cucumber gets a lot of the credit in the testing world for being this great tool that helps all these problems, but really Cucumber is taking credit for all the important things, the conversations, the discussion, the questioning why you're building things. And to me, you don't have to use Cucumber to gain this value. Really, it's about the conversations and not the tooling. Cucumber is not the only way. So we love metrics. We're obsessed with testing and recording vast number of things about our users, how they interact. Again, in terms of measuring success of our features, often it could be from measuring the sign-up rate. The sign-up rate went up like 15% of the Facebook users, so we assess that as a successful feature. This is required for like continuous deployment stuff, rolling stuff onto production. You need like really tight metrics because you need to be able to detect if someone can't buy something on your site anymore. I want to know that in production as rapidly as possible, especially if I'm making that decision on the speed side of that equation rather than the safety. Briefly, I also wanted to mention something we use called limited red, which is a tool I wrote, again, about metrics. But this records metrics about pretty much every test any developer runs, and on our continuous integration server. We use this tool to prioritize the probability of failure. So this comes from a very simple idea that I think Apple originally did in Ireland with their manufacturing plant, where it took them 3 days to test a new iMac. And then what they started to do was find the tests that were failing, and then rather than running over 3 days, run over 4 hours and just run the tests that were most likely to fail. So this takes that idea and applies it to our software. If you're working, if like one developer is touching a bunch of code and some tests are failing as they're working locally, and some other developer is working and breaking a bunch of tests, when those two developers merge their code up, we have a statistical model which indicates the tests that they've been touching, and hence what's most likely to fail. Also, we can do really smart stuff like, often this feature fail, this test fail because, if this thing's changed, this thing over here often can fail. So we just use a lot of statistics to gain a lot of value about how we run our tests. And in terms of the developer, I can use this to measure how I'm working. If I spend like an hour in the red tests, I get this sort of feedback loop where I can look at this admin interface and see, that's not good, I perhaps need to think about how I approach that problem when I spent an hour sitting in a red test. Running out of time, so very briefly, also what we get from the statistics, we use it to identify smells in our software. So this represents all our Cucumber features. Not all of them, actually, I can fit them all on. This red here represents the failure rates of these features, and this grey here represents the number of times these feature files have been changed in our source control system. So what this enabled us to do was compare the failure rate with the change rate of the feature. So like this thing here was changed 46 times, and you can see this test didn't fail that many times. But we can have something like this, right? This was changed once in its entire lifetime. So the feature file of Cucumber means some behavior of this feature was changed. But what, this thing, I can't read that, I think it failed like 8 or 9 times. So that is an indicator that there is something in the system, there's a smell, right? There may be something that's too coupled to this feature, maybe it's a fragile test, maybe it's bad architecture, we need better separation of concerns. So again, like our obsession with metrics doesn't just come down to the way we do continuous deployment, the way we measure success of features. It also comes down to the way we execute and learn about our system and our code. So that pretty much sums up everything I hopefully wanted to cover. I hope that was kind of interesting and I didn't go too fast. I guess I got a little bit of time for a couple of questions. Okay, so anyone got any questions? If anyone has any questions, I'm happy to answer. Or you can come see me after if you want and ask anything.
Why do you have a feedback button on your...
Microphone.
Я уже нету времени.
Давай. Все.
Why do you have a feedback button on your tools, engineering tools? So,
You mean the deployment stuff on
yes.
why we have a button? Because it provides logging through a build tool source, we get a console log of every build that's run. So we can use that as an audit to work out what's been deployed. Ultimately, we want to get that automated, but at the moment, we want like the idea that anyone can come into the team and they can start choosing to deploy code. So someone in the production, like someone who's a product developer, who's working much more on the management sort of side of things, can come along and can say, all right, like so I can deploy the code. Like, you want that feature? Yeah, you go hit the deploy button. It's ready for it's green. It's ready to go. So it reduces the barrier for deployment compared to running, like in the Ruby world, running some Unix command like cat deploy or... No? Did I not understand that?
The button was feedback. Give a feedback.
The feedback button.
You
Let's go back.
showed the slide? Yes, that was... No. Okay.
We're going too far. Is it further back?
Oh. But there's your tool or web page of tool, not here.
Let's go animation.
No, here. That was not.
Okay. Running animation.
Feedback, green button.
Oh yes. It's using a tool called User Voice, I think, which is simply a way of getting users to. It's like a little pop-up. It comes up. It says like, what do you want? What features do you want? Is this site useful? So it's a way of extracting feedback from people using the website. So often we have this on a lot of our apps just because it provides a really nice way of users saying, I want this feature, or I don't want this feature.
So it's not related to acceptance testing, it's just related to tool.
So it's for users, it's not for engineers.
It's for users, yes, and it is used by engineers to decide what they want to build. Question? Cool, thanks very much.